Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about generics. This is yet another really powerful C# feature. This one lets you write code that can be used with a multitude of types. Okay, so let's learn about generics, and we've actually already seen them in action in a bunch of places. For example, quite a long time ago we learned about list, and the list, this type requires putting another type within those angle brackets. This right here, for example, list of int, this is what is called the generic. The list type works with generics, which means it can work with any type. So we can make a list of ints, we can make a list of strings, we can make a list of program types, and so on. If it did not have generics, then we would need to create a separate list class for every single type we wanted to use it with. That would definitely not be very fun, not very easy to use. Whereas with generics, we just define the list class just once, just one time, and then that class can work with any type we want. Also, same thing when we saw the delegates. So we saw, for example, the action, and we saw this one has all kinds of parameters. So we can have an action that takes in a parameter of type int, we can have a type string, we can have a type bool, and so on. Same thing for the func. So again, there's no need to create a specific action class that works specifically with an int, another one specifically with a float, and so on. The action class itself, that one is made to work with generics. It takes a generic T type, and that type can be whatever you want. Now, one of the best practical examples of how useful generics are is actually my grid system playlist. I've built a ton of interesting systems and games on top of that base system, and the reason why I could do that is because the grid system itself, that one is made to work with generics. Here is that class, the grid class with generics. Here it works with a generic type that I named tGridObject, so I can define a specific grid that works with a specific type. Again, it could be something simple like an int, a float, bool, and so on, or it can be a specific custom grid object class that I define. And with that grid object, I can place whatever custom data I want, and the grid system will work perfectly with it. So I don't need to make a brand new grid system for every kind of thing that I want to do with a grid. I just use the exact same grid system for any type, and by writing this class using generics, by doing that, I managed to reuse this base class and build all those complex systems that I made in all those videos. So how we make a generic class is actually really simple. We just write the class name as usual. For example, let's make our own custom list. So let's make a class, let's call it myList, and then we put our angle brackets. And inside, here we give our generic type of name, and technically you can give it whatever name you want, there's no rules here. However, usually the convention is to name this T for type, and alternatively, if you have multiple types, the convention is to use T, and then perhaps a number, so T1, T2, T3, so this is what the action uses. Or alternatively, if you want a more descriptive name, usually, once again, you would still start the type with T, and then pass in something like, for example, TUnit. Another example of generics that we've also already seen is the dictionary, and if we look inside the dictionary, yep, this one named the generics T-key and T-value. So yep, you can write whatever you want, but over here, let's just write a T, so just like this. So here we have our class with a generic type, and now inside of this code, we can use the type T. So for example, let's make a public field of type T. So yep, just like this. Now importantly is how T doesn't really exist. We don't have any class named specifically T. T is really just a name that we defined. This can be whatever class we're going to use it with. So when we use our myList with of type int, then this field will be an int field. So this is our basic class, and now up here we can make a new, let's create a new myList, and then for type, let's go with int, just like this. So this is a myList of type int, and over here we can go inside, access the field, and yep, note how this field is indeed of type int. And yep, so this does work. Then for example, let's say we want this class to work with bools. Again, since we are using generics, we don't need to make another class definition. We can just go up here, make another myList, in this case of type bool. Let's name it by myList, and then do a new int of bool. And now we can go inside, we can access the field, and yep, this one is now a field of type bool. So over here we have two instances of our class, and each of them is working with a different underlying type. Then in our generic, we define our type T. We're using it over here in the field, but we can also define some kind of functions. For example, let's make a private void my function, and we can receive a parameter of type T. Or alternatively, we can make it return of type T and take in no parameters. Also, by the way, one quick tip, since over here we do not know what type T is going to be, since we don't know that, then for example, we cannot return null. This does not work. And the reason why it does not work is because T technically could be a non-nullable value type. Like for example up here, when we are creating our list of ints or bools, these are not nullable values. These are value types, not reference types. So because of that, over here we cannot return null. So if you do have some kind of logic that is meant to return a default value, instead of returning null, instead of that, you can use the keyword default, and this will return either null on a reference type or the zero equivalent on some kind of value type. So for example, let's do this, let's make it public, and then up here let's call it. So let's call my function, let's put a right line on this. Let's see what default value is for both these. So let's see. And if there it is, the default value for an int is 0, default value for a bool is false. Then on the generic definition, over here, like we saw, we can already define more than one type. So we can define T1, T2, T3, and so on. We can do this, and then we can use different types in our code. This works. So here we have our generic class, but we can also use generics without making an entire class generic. We can have just a single function. So over here, let's make a test function. And on the function itself, let's make that function work with generics. The way we do it is really the same thing. So after the function name, we put the angle brackets, then some kind of generic name. And now we can use this type in any way. Like for example, use it over here for a parameter, or we can use it for the return type. And yep, everything works exactly the same. Over here, let's do a console.writeLine. Let's print out p. And for example, up here, let's call out this one. And we can call in with an int. And yep, this works. We can call in with a string. And yep, it also works. Call in with a char. Yep, this works. Call in with a boolean. And yep, this also works. So here we have a function. The function was defined with generics, which means that we can run this function with whatever type we want. Then you can also make structs that use generics. So instead of a class, this can be a struct. And yep, structs can also use generics. Another one is also on interfaces. So up here, we can define an interface, my interface. And on this one, we can also use a custom type. And then we can use this type, like for example, some kind of function that returns of type t. Yep, this is also valid. So lots of use cases for how you can define generics and how you can use them. Another extremely useful thing we can do is simply apply some type constraints to t. Right now we have no constraints, meaning this can be used with any type for the generic. It can be ints, bools, some kind of custom player class. It can be literally anything. Now let's say, for example, we want this one to only work with classes. For that, we can go over here into the class definition. And afterwards, we write the keyword where, and then our generic type, so in this case t, and then put a colon, and then let's say, for example, class. Meaning that this type MyList can only be used with a t type as long as that type is of type class. So like for example, here we see some errors because ints and bools, these are not classes, so we cannot use with those. We need to make some kind of class for some kind of player. And now up here, we can make this of type player. And yep, now this does work. And again, the issue that we saw a while ago on how we cannot return null from this one. But if we do enforce that t has to be of type class, classes can always be null, so now we can indeed use null here. Then another interesting constraint is, let's say for example, we want to construct whatever type we use here. And right now, if over here on this function, if I try to do new t, if I do this, nope, there's an error. Again, same thing, we cannot do it because we have no guarantee that whatever type we use here, whatever type we use has some kind of constructor. In order to make that work, again, we can apply another constraint. In this case, this one is named new, just like this. So now we can use this class with any generic type as long as that generic type is a class and has a parameterless constructor. Which over here, the player by default has some kind of parameterless constructor. So yep, this one is perfectly valid code. And over here, yep, we can do new t in order to construct a brand new player. For example, we can put this on that one, and this one is going to construct a new object of type p, which in this case is going to be the player. So when we run this, it should say something of type player. And if there it is, it's done like that. There's a bunch of really useful constraints we can apply to our generic type. There's a great list on the C# docs. We can see how we can force t in order to be of type struct, of type class. We can ensure that it is a non-nullable type. We can ensure that it has a parameterless constructor. Or one of the most useful ones are simply these ones, basically requiring t to extend some kind of base class or implement some kind of interface. And all of these work on a class definition, but also over here on just a single function. So again, where t is a class, and now it ensures that we can only call this function with a type that is actually a class. And when using the one that enforces that it extends some kind of interface, for example, let's make a function get attack winner, and let's receive two types, t1 and t2. Or actually, let's give it proper names, so t attackable and t defendable. Then we receive those. So we can enforce that t attackable does have to implement the iAttackable interface. And we can enforce that t defendable has to implement the iDefendable interface. And now since we've applied these constraints, because of that, now we can assume some things about these types. For example, we can go inside our attackable object and we can call get attack points. Then we can go into the defendable and call the get defense points just like this. Now with this, if we had a player type that implements both these interfaces and a unit enemy type that also implements both of them, if so, we could call this function and pass in either two players or a player and an enemy or two enemies. And all of this logic would work because all of them match the perfect generic constraints that we have. So that means that this function, this single function, is really adaptable and can be used with a ton of different types. Whereas if we were to remove these, then nope, we cannot access these functions because we have no guarantee that whatever types we use here will actually have these interfaces. And generally, one of the best benefits of generics is how they make your code type safe, meaning they help you avoid errors when using incompatible types. For example, let's say we have some kind of resource, so we have a type for gold, a type for wood, and then we have an inventory class that takes in a generic type. So then up here, we created different inventories, one for gold, one for wood. If we go inside the gold inventory, and we try to add, and let's try to add some wood. If we do this, then nope, obviously this one throws an error. This is how generics help us by making our code type safe. If we make an object of a type, and we define that this one only works with gold types, if so, then we cannot add some wood on there. The type itself is going to be forced as soon as we create the object, and we cannot break that rule. Alright, so those are generics. It's another extremely useful C# feature. I use them all the time. They are super useful for making your code really adaptable. So definitely make sure you fully understand this and make sure you use it whenever you need to. This is really powerful, but also for beginners might be a little bit confusing. So if you feel a little bit lost, maybe go rewatch this lecture one more time, maybe go inspect the demo, and definitely make sure you do all of the interactive exercises. This is a really powerful feature you definitely must know about.